Today we are starting section 5.2 and it's our introduction to logarithmic functions. Okay, so I think we're going to spend about 3 days again on this section. So let's go ahead and get started. So it says for a function to have an inverse, and you might remember this from Algebra 2 or Algebra 3, the function must be one-to-one. Okay, so we're going to think back to our exponential functions we just worked with. So f of x is equal to a to x. We know that's an exponential function from last section, not chapter. And we know that passes the horizontal line test and is one-to-one. So therefore, we know it has an inverse. And the inverse of an exponential function is a logarithmic function with base a. Now, we typically just say log function, okay? So to give you a little bit more of a mathematical definition of a log function, it says our x value has to be greater than 0, our a value has to be greater than 0, but a cannot be 1. Okay, so if those are true, we know that y, or f of x, is equal to log base a of x. Okay, so that's how we say it, and we'll write that down here in a little bit. If and only if x equals a to the y. So this right here is how we are going to transform, I guess I should include that, log functions into exponential functions. So we can work with them a little bit and understand how log functions work. Okay, so it says the function given by f of x equals log base a of x, and we read that as, just like I said, log base a of x is called the logarithmic function with base a. I'll just write log function with base a. All right, so anytime you guys need to, just pause this video. That way you can catch up if I go too quickly. All right, so moving along, a numerical example of this to make it a little bit easier for us to understand, it says if we have 2 equals log base 3 of 9, we can rewrite that until we get used to seeing the logarithmic functions to sort of understand what they mean. So what that means is that 9 is equal to 3 squared. Or if I take the base and square it, it will equal that 9 value. Okay? So again, if I have 5 to the third, we know that equals 125. So our base is 5. Our exponent is 3, and we know that's equal to 125. So the only thing you have to remember is the base of an exponential function is still the base of the log function. The exponent is what it equals. So exponent equals both start with e. This is one little way to help you try to remember what goes where. So now let's see if we can rewrite some of these. So write each exponential function as a log function. Okay, so 4 cubed equals 64. We know that's a true statement. So our base of this is 4, so we're going to do log base 4. What it equals is the exponent, so that means log base 4 of 64 is 3. Okay, so let's take a look at b. We need to write this as a log function, so I have log, my base is 9. 27 goes here because what it equals is the exponent. All right, so pause the video, try the next 2 your turns, and then come back to the video and see if you got those 2 correct. All right, so hopefully for the first one, you got log base 8 of 64 is equal to 2. And for part B, you got log base 81 of 3 is equal to 1/4. All right, next example, we're going to see if we can start to evaluate some of these without a calculator, because our calculator, and we'll look at this here on the second half, is in base 10. There is a way to change it, and we'll get into that eventually, but for now we just need to understand sort of what to do and how to figure them out. So it says use the definition of log functions to evaluate each logarithm at the indicated value of x. So the first thing I'm going to do is replace the x value right here with what they told me it needs to be, okay? So this becomes log base 2 of 32 equals what? So remember, if we are using exponential functions, we would say 2 is my base, what it equals is my exponent, and then 32 goes there. So what power can I raise 2 to get 32? So if you needed to, you could get your calculator out, and you could do 2 squared, that's 4. 2 cubed, 2 to the 4th. We're getting closer, 2 to the 5th. So 2 to the 5th is equal to 32, so that must mean that log base 2 of 32 is equal to 5. And we're all done with that one. All right, let's take a look at B. So each of these are a little bit different. So I'm going to replace x with 1 because that's what they told me x is equal to. So log base 3 of 1 equals what? So that means 3 to what exponent will give me 1? Well, this is a property that on the back side of this paper, we are going to notice that anything, or if you remember, anything to the 0 power is 1. So therefore, 3 to the 0 power is 1. So that must mean that log base 3 of 1 is equal to 0. All right, let's move down to C. All right, I'm going to replace the x with 2. So we have log base 4 of 2 is equal to what? So we need to think. 4 to what exponent will give me 2? Now here we have to think a little bit, because normally when we raise a number to an exponent, the number gets larger. But in this case, my number got smaller. So we have 2 ways to think about it. We know if we're thinking of an exponent form, it's going to have to be a fraction. But we also know that a fractional exponent means a square root. So like if I had x to the 1/2 power, that really is the square root of x. So what number, if I take the square root, cubed root, fourth root, will I get 2 as my answer? Well, if I take the square root of 4, that's 2. And we know that square root is really to the 1/2 power, so that must mean that log base 4 of 2 is equal to 1/2. Okay, so we always relate it to our exponents, at least for now, until we get the hang of it, to try to figure out what the log is equal to. All right, we have one more, and then you guys are going to try a couple. So this one, again, replace my x with 1 over 100. This one looks like fun. Okay, so again, let's rewrite it in exponential form. So 10 to what power is 1 over 100? All right, now, thinking again, what type of exponent do we have to make a whole number become a fraction? Okay, we need to take a whole number into a fraction. Well, the only way to make a whole number into a fraction is with a negative exponent. Okay, so if I had 10 to the negative 1, that would be 1 over 10. So we're pretty close. We at least have it in fraction form, but now we need to make 10 into 100. So I don't want 10 to the negative 1 because that gives me 1 over 10. What will make 10 into 100? Well, squaring 10 will make it into 100. So what if we do 10 to the negative 2 power? So that would be 10, or 1 over 10 squared, and 10 squared is 100. So that must mean that log base 10 of 1/100th is negative 2. Okay, and I am sure this is all completely new to you guys. So we're basically just doing this today and practicing that. All right, so you guys have 4 your turns again. So So pause the video, take a moment, and see if you're able to answer those 4. Okay, so hopefully you were able to figure those out. I tried to write my thought process down as I went. The only one that might be a little bit different, because I don't think we did this one, would be B. So 2 to log base 2 of 2 is equal to what? So 2 to what exponent will give me 2? And I accidentally wrote in there. So 2 to the first gives me 2. So log base 2 of 2 is equal to 1. All right. So I'm going to sort of skip a little bit down here, because what we just did, all 4 problems we did, well, I shouldn't say all 4 because number 4 is a little bit different, were properties of logs. So just common properties that if you understand and learn them, it will save you some time. So the first one is log base anything of 1 is equal to 0, because anything to the 0 power is 1. The second property is log base a of a. So if I have log base 5 of 5, log base 10 of 10, log base 100 of 100, it's always going to equal 1, because a to the first power is always equal to a. Okay, so it's sort of like these all cancel out and we're left with 1. All right, and then we have log base a of a to the x. This one looks a little bit different, is equal to x. And the reason it does is because log base a of a is just a 1. So then we have x is equal to x. And a better way to look at it is because if I have a to the log base a, they cancel, and we're left with x. Okay. And finally, I call this one the one-to-one property of logs, because it says if I have log base a of x equals log base a of y, then we know x must equal y, because they have the same log base a. So sort of like the one-to-one property for logarithms. All right, so let's go up here. We're going to look at what's called the common log. The common log function is a logarithmic function with base 10, and this is what your calculator's used to. So it is denoted, whoops, let me make that a little smaller, by log base 10, or if you just see the word log, we know that is meant to be log base 10. So if it is anything other than base 10, you have to write it. All right, so next example is just figuring out how do we do this in the calculator. So it says use a calculator to evaluate the function given by f of x equals log of x at each value of x. So I'm going to rewrite this. So this is really, so we're starting all of our functions with log base 10 of x, so log of x. So this right here would be log of 10. So get your graphing calculator. The log button, I wish you could see me pointing here, but it is on the left-hand side, 1, 2, 3, 4, under the alpha button. So I'm just going to push that and we get log, and I'm going to do 10, close my parenthesis, and we get 1. But if we think about that, because if it's log base 10 of 10, remember, we just get 1, because 10 to the first gives me 10. Okay, let's keep going. B is log of 1/3. So if I type that in, log of 1 divided by 3, we get negative 0.4771. And we'll do about 4 decimal points as well. Let me highlight my answers. All right, now we have log of 2.5. Let me write this down. Log of 2.5, we get 0.3979. All right, and you guys do the last one and see what you get. I gave you a tricky one. So this is going to be log of negative 2. And that gives me not a real number. So no real numbers. Oh, that means all real numbers. Let me do no real number. There we go. Okay, so let's think about that. So I would say 10 to what exponent gives me negative 2? And if you think about it, there is no way that I could take 10 and raise it to an exponent and get the value of negative 2. It just doesn't happen. Okay? All right. The last thing we are going to do is try solving some of these using those properties we looked at. Okay? So, and we'll use our exponent functions to sort of help us here a little bit. So it says log base 7 of what number is equal to 1? So the only way for me to get a 1 out here is if these two values are the same. So that must mean that it is log base 7 of 7 equals 1. So x must equal 7. Okay, so I want you to try these for your turns. They're all using the properties above and see what you get as your answers. So pause the video, look at the properties, and eventually you'll do these enough that you'll know these properties. All right, so log base 4 of 1. If I get a 1 here, that means it has to be a 0. Log base root 7 of 7 is equal to 1. Okay, oh, I see 6 to the log base 6. They cancel, so I'm just left with 20 as my answer. And for these two, I notice, hey, I have the same log functions. So I'm going to set x squared minus 6 equal to 10, which means I'm going to add 6 to both sides, and I get 16. And then I'm going to square root both sides. So the square root of 16 is plus or minus 4. So that's just using basic properties. All right, so I did not bring my practice packet home. So you can look in Schoology and see what your practice work is. I do apologize, the page number is probably not going to match up, but it is whatever the first page is of section 5.2.